Okay, I decided to record this video because I was contacted by a group of students. I was contacted by a group of students from one of the universities in London. They asked me to teach them actually for their research exams in networking. Upon talking to them, I realized that they had a few confusions about DHCP, NAT, PAT, PPP, frame relay. And in fact, the exams they failed contained all these lot. So I decided to record a quick video for the benefit of those of you aspiring to be network engineers, especially those of you getting on the Cisco certification ladder. By way of introduction, my name is Isaac Akpotsi. I'm a CCNA and a computer network security professional. I hope you enjoyed this video, and I hope this video explains some concepts that you sort of are confused about. And don't forget to leave me your comments when you watch this video, okay? And suggest to me any other video you would want me to record for you, okay? All right, so without further ado, all right, first of all, this is a very simple topology that I came up with just to show you how to design, how to configure DHCP on a Cisco router. I think the confusion here is that a lot of people don't know how to configure the router, especially when multiple subnets are involved. And so I'd like you to watch carefully and follow me as much as you can. All right, so let's start this. Okay, first of all, I've set up the topology. I've given them. I haven't configured anything, the routers, everything is fresh because I wanted to start right from the beginning with you. All right, so the link here is our link to the internet. Okay, and I've given it a /30 address. What we have here is our internet host. It could be a server, anybody on the internet, and so on. And we have our internet service provider. The router is simulating that. At some point towards the end of the tutorial, I'll bring in that cloud. This cloud is to be configured as a frame relay switch. So let's get into some configuration. First of all, we need to do some IP addressing. So let's do this from the command line. As you can see, the router is fresh. Let's just say no. I don't like configuring router using the auto configuration wizard. All right, so let's do this. First of all, enter. Let's get into privilege mode, configure terminal, and let's secure the router because it's a perimeter router. All right, so it's an interior router, so let's secure it. First of all, what you want to disable is DNS lookup, so no IP domain -lookup. Okay, this will save you a ton of time. Okay, now enable secret. Cisco username. I like using the username option. Username admin privilege 15. I like that. I like to do setting up by securing my routers in that way. Secret instead of password. Let's say Cisco 1234. Okay. Line con 0, login local. You're telling the router to look for login credentials from the local database stored in the router. Okay, so let's secure the VTY lines. You know, my brain goes faster than my fingers, so pardon me. Login local. Okay, and let's do this. Exit to global line interface. Interface FA0/0. We said FA0/0 according to our diagram here, topology here, is our well, is for network A. Okay, so let's give it some addressing. IP address. Let's call this 192.168.1.254. That's the last address for that subnet. And the mask is, of course, 255.255.255.0. Okay, because command. Okay, and the port goes up. Let's do this. Interface FA0/1. IP address. Let's give it a 10.1.1.254. Again, the last address for the subnet, and let's give it a 255.255.255.0 because it's a /24. Okay, and let's enable the port with a no shutdown command. Okay, the port is up. Now let's do some addressing for the serial interface. So interface serial 0/0/0. Okay, and this is IP address 209.165.100.2. Okay, and let's give it a 255.255.255.252. It's a point-to-point link. Yeah, no shot. Okay, and that turns the port on. What to do is to set up our DHCP because currently the computers in the subnet don't have IP addresses. It's either we give it a static address or configure it to seek for addressing parameters from the router or DHCP server. In this case, let's do this. Let's try this and see. Of course, it's going to fail because DHCP is not configured on the router. So let's try configuring DHCP right here on the router. Remember, we'll have two subnets and we want the router to release addresses to those subnets. Okay, so let's do that. First of all, DHCP, to configure DHCP, we need to be in global configuration mode. Yeah, and then set up our excluded address if it's necessary. If it's not, don't set up. If you want to exclude some addresses to be released to computers, other hosts on the network, then you do exclude some addresses. For example, reasons why we exclude some addresses is to give those addresses statically to devices like server, printers, and so on. Devices that don't need their addresses to regularly or frequently changed. So ensure you exclude some addresses for such devices on the network. Okay, all right. So IP DHCP, that's the command you need excluded, and that completes it for you. For subnet A, we want to exclude for the first address to the 10th address. So 192.168.1.1, and then the upper range is 192.168.1.10. Okay, these are the addresses we want to exclude. Now, IP DHCP, we need to create a pool, for the addresses. DHCP pool. Let's call this pool net 192. Why? Because that is for the 192 network. Okay, and let's define the network for those addresses. So network 192.168.1.0, and don't forget to bring the subnet mask. Okay, if you forget the subnet mask, it won't work. Number two, your DHCP list, if you forget the network command, your DHCP won't function. Okay, so bear that in mind. So that is the network command done. That's 192.168.1.0.255.255.255.0. Network is done. Now let's configure the default, called the default gateway for those computers in the network. Default router will be 192.168.1.254, and that's the default router. Should you need to configure default DNS server, then you use the DNS server command. DNS server command, and let's, for the sake of argument, let's just use the same route as the DNS server. Okay, so that will be 192.168.1.254. Okay, and then we enter. So that's done pretty much. And we need to do the same thing for the subnet B. That's the network 10. Okay, so let's go back to global configuration mode. Yeah, then IP DHCP excluded addresses. We want to exclude the first 10 addresses. So 10.1.1.1 to 10.1.1.10.1.10. Okay, these are the addresses we want to exclude. Then IP DHCP pool. Let's call this pool net 10 because it's for the 10 network. Okay, net 10. All right, and now let's do network. Let's define the network where the addresses will be released from. Network 10.1.1.0. All right, and let's set the default router 10.1.1.254. Remember, 254 is the interface of Fast Ethernet 0.1. Okay, now default router, also called default gateway, is the exit point for traffic coming from each of the subnets. Okay, for example, if you want to go from your house to the shopping mall, okay, the only way you can get out of your house, when all windows, of course, are closed, the only way you can get out of your house is to go out through your front door. Okay, and the front door becomes your default gateway to go out. All right. In the same case, if traffic is to leave the subnet over here, all right, to go to another subnet or the internet, that traffic will have to pass through the default gateway, which is the point here, right? That is the Fast Ethernet 0.1 interface here. And so by configuring the default gateway, we are telling the router that any device that wants to send traffic outside its own network must go through it. All right, go through that interface to the other networks. Okay, so that's what pretty much is happening here. Now we need to tell this switch. All right, as far as communication is within the LAN, the default gateway will not be used. But when communication is to cross the LAN to a different LAN, default gateway is used. Okay. Now, traffic in the switch must be configured to forward traffic coming to it or arriving at the switch to be able to be forwarded or switched to the router's interface. So on the switch, we need to configure our default gateway, IP default gateway. So let's go into global configuration mode, conf-t. I want to disable domain services here, IP domain -lookup. Okay, saves us a lot of time. Okay, now IP default gateway, we want to call this 10.1.1.254. Okay, so much like let's just explain this one. The switch is pretty much like someone acting as someone giving direction. You know, say you're going somewhere and you don't know a specific location you're going to, and you ask someone, a passerby or someone whom you think will know where you're going. You ask the person for direction, and the person directs you to wherever you intend going. The switch is acting like that, sort of. Within the network, when traffic is destined outside the network, the switch receives that traffic and forwards it based on the default gateway's configuration on the switch. So the switch receives it and says, okay, oh, you want to get to this network, or this is the direction. Let me forward your traffic to the nearest hub, okay? And that is the router's interface. So that's what is happening here with the default gateway command. And you see the 10.1.1.254 here is the same IP address, okay, for this interface over here, okay? So that is what is happening here. So we've set that. Let's also set the default gateway on this switch, okay? The first thing we want to do is we want to go into configuration mode, yeah, and then we want to disable domain lookup. All right, I always say, to be honest, I've trained myself to disable that every time first, because I've struggled in exams with this thing before, when it wouldn't stop searching and time was really running so fast. Okay, so let's do this. IP default gateway. We want to configure it as 192.168.1.254, same as the previous explanation I gave you. All right, so let's do write to mem, much like copy running configuration to startup configuration. Let's write to mem over here as well. Yeah, so let's do write mem. I like this command because it's simpler and it does the job. Okay, all right. So now we're done. Now you remember initially our PCs couldn't get the IP addresses from the DHCP server, which is the router. Let's try this time and see whether they've got addresses. There you go. An address has been leased to the switch, the PC. Okay, let's try it again. And there you go. The address DHCP request is successful. Let's see other PCs in the same subnet and see whether they are getting the addresses. There you go. And remember, we excluded up to 10, the first 10 addresses. And so you see the switch, the router starts leasing addresses from 11. And that is what we're seeing here. If you're wondering why it's 12, 10.1.1.12. This, I suppose, by calculation will be 13. So let's try that and see. There you go, 13. So any device that is added here will get an address. Let's just try that. Let's say we put a server here. Let's put a server here. And we want the local server to get an address via DHCP. All right. Let's do this. It's not going to let it now because we haven't connected it. So let's connect it and see. Receive your address server. And there's the magic. Server should receive address after a few seconds. Okay. Let's try it and see. Yeah, it's going to receive it anyway. Don't worry. It has to send DHCP request and all that, and all the processes that goes on behind the scenes. DHCP request, DHCP offer, and all those things. Read on DHCP. I'm just demonstrating the topology to you now, but you have to read if you want to understand. So there you go. The next address has been issued or leased to the server. So everything is working on DHCP. Let's try this one, this subnet, and see if everything is working. DHCP. There you go. This subnet is also working. Let's enable all the PCs here to get the addresses from DHCP. So all is good and as intended. So okay, so all addresses are working. I'm sure this one is got its address now. Yeah. Okay. So DHCP, there you go, is functioning. The next thing we want to do is to set up our PPP link. Okay. It's very simple to set up PPP. We want to go to global configuration and say interface serial 0/0/0. All right. Let's encapsulate it, PPP. Yeah. And let's give it a bit of description. Description is link to ISP. Yeah. And that's our description. Okay. Next thing we want to do is to come to the internet router. All right. So you can see it's fresh. Let's say no. We want to enable. Let's secure the router. I like doing that. Yeah. Conf t. Let's give it a host name. Yeah. Host ISP. All right. Yeah. Enable. Let's enable secret. Let's call Cisco. Yeah. Let's use the username. Admin. Pass. Privilege. 15. Pass. Let's do secret. Cisco 1, 2, 3, 4. All right. And let's secure the console interfaces from unauthorized access. All right. So login local. All right. Line VTY 0 to 4. Yeah. Login local. All right. Log sync. I like using that because it allows you to type without interruption. Okay. Alright, so that's done. We've secured the router. Now let's do some interface configuration. Interface serial 0/0/0. Let's encapsulate that PPP. Yeah. Let's give it some IP address. IP address 209.165.100.1. Okay. 255.255.255.252. Okay. Remember, this is the same address we gave the other address because it's a /30. We gave the second address to this interface, the serial interface on the interior router, and then for point-to-point connection, of course, the addresses must be in the same subnet. Okay. And so ensure, that's one mistake I realize people do as well. They don't ensure that the addresses on the point-to-point link are the same, are in the same subnet. Okay, make sure the addresses must not be the same. For example, you have a 192.168.1.1, and then you put the same thing here. No, that's not what I'm saying. I think I came across an error like that from one of my students. No. The addresses must be in the same subnet, but they must be different. So, for example, if you issue the first address, IP address to this interface, you should issue the second address to this interface. That's what it is. And a lot of times, point-to-point addressing is /30. All right, in order not to waste any addresses, point-to-point should mostly or always be a /30, which is a 252 subnet. Okay. So that's done. Now let's set the clock rate because I want the internet service provider to send me the clock rate. So clock rate to be 64,000. Okay. And let's enable the port with the no shut command. There you go. The port goes green. Okay. Now what we want to do is to do some testing. There you go. Change state to up so the link can communicate now. Okay. encapsulation is the same on both ends, and so there is link communication. Sometimes, if the addresses aren't correct, you will send a packet. For example, when you use it doing this in Packet Tracer, you can send a packet from here to here, and it will be successful. But don't be fooled. Once the addresses aren't correct, you still can get some packets delivered when you're dropping on the routers. But ping will not work because layer 3 addressing over there on that point-to-point link isn't correct. You'll have layer 2 working, but layer 3 will not work. So make sure that the addressing on both ends are correctly configured. Okay? Alright. So here we go. We have a success. Now if I do a layer 3 ping, of course you should know by now that ping resides in layer 3. Okay? So Control C, and let's do a ping. Ping 209.165.100.1 because that's the address of the ISP interface. And here we are, we have 100% success. So layer 3 is working, layer 2 is working. All right. And let me just mention one good diagnostic tool. I call it tool, but it's a command really. Show IP interface brief. This is a very good command, and I use it a lot. It tells you, gives you a snapshot of the state of your ports that are in use. Very good. As you can see, my fast Ethernet, my serial interface is up, layer 2, layer 1 is up, layer 2 is up. This IP address, this is the IP address assigned to that port, and so on. The same for all the interfaces that are in use. So show IP interface brief is a fantastic command for diagnostics. Okay, let's go to this and give the internet host some IP address, the link to the internet host some IP address. So let's do interface fast Ethernet 0/0. Let's give it an IP address of 10.2.2.254 as usual. 255.255.255.0. Okay, let's enable the port. Okay, now let's come to this PC. Before I go there, let me do right, man. Okay, let's come to this PC and give it a static addressing. So let's give it a 10.2.2.10. Okay, and let's give it a 255.255.255 address. 255.255.255. Oh, thing is running too fast. Let's give it a default gateway of 10.2.2.254. That's the default gateway. Okay, we can drop some packets on it and see if it's communicating with the router. The link is successful. There we go. Okay, so all is working. For traffic to get to the internet, we need to forward traffic because we don't have routing set up in the network. So let's just look at something. I'm a PC here in LAN B. I want to communicate to a host on the internet, and let's say it should fail because some configurations hasn't been done. So let's see. There you go, failed. All right, let's try it again. We will fail till thy kingdom come. Okay. So we need to configure default routes or on the switch on the router over here. So let's go ahead and do that. Config T IP route, yeah, 0.0.0.0 0.0.0.0. Okay, and we want to use the interface of the next hop router. Okay, that's 100.1. Okay, and that's the interface. IP route, I'm sure you know the default route command. All right, what is telling the router for any packet arriving here with sort of any packet arriving here bound for the internet, just forward it via this interface, the interface connected to the ISP. So that's pretty much what is happening here. All right. Okay. Now we need to set the same thing on the service provider, the router. Okay. So that traffic arriving at the router, bound for the internal network, all right, traffic arriving at the router or the service provider will be straight away forwarded to the internal router. Okay, there's so many ways we can do this. Like, let's do it the easy way by using the default route. We can also define the network. All right, that should the network in the packet. All right, upon which the router will decide where to forward that traffic to. All right, but yes, let's make it very easy for ourselves. So IP route, let's exit one point. IP route 0.0.0.0 0.0.0.0, and let's use the next hop internet let's hop IP address. Okay, next hop is 209.165.100.2. I'm using 100.2. I used 100.1 because the traffic was to travel from here, interior router, onto the internet. So the interface here is what I use. Now remember, you can also use the exit interface name as well. Okay, so for over here we could have used interface serial 000. Okay, we could have used interface serial 000 as well instead of the next hop IP address, but I prefer the next hop IP address. Why? Because it's very specific and it will only go to the next hop IP address, period. Okay, so I prefer using it. In the past, I've configured some routers and I used the serial, the interface name, and I had some problems. But as soon as I used the IP address, the next hop IP address, it worked flawlessly. So from then I decided, I'll keep to that. So yeah, there you go. Just in case you come across the same thing, please just use the next hop IP address and it works perfectly. Okay. All right. So over here, defining the IP route, default route, I use the address here because I'm telling the router for any traffic arriving here bound for the network here, forward it to this router here. So you use this IP address, which is sort of the sort of direction to this route, the IP address. So the router receives, okay, I know where 209.165.100.2 is located. So okay, I'll forward the traffic to the interface or to this router here. So that's what is happening. That's what the command over here is doing. Okay, all right. So that is done. Now, having done that, let's see. Remember, we tried to send traffic over the internet. Let's see whether it works this time. There you go, success, because we've defined the default routes. Okay, let's send the traffic from the server to the PC over there, and that's successful. Okay, let's try one more time from a different network B, and send it to the internet, and that is successful. So everything so far is working as it should. Now the next thing we want to do is to do the PAT, okay, port address translation or NAT overload. Okay, first of all, what we want to do is to set up our addressing IP address pool, okay, or global IP address pool. Again, we do that when we have more than one global addresses to use, then we set a pool. But in this case, we're not going to set up the pool because we only assuming that there's only one global IP address to use. Okay, so we have to enable the exercise is really part, not dynamic NAT or static NAT. So let's concentrate on part where we have only one IP address. Okay. All right. So first of all, we need to define our inside and outside interfaces. And if you look at the topology, yeah, fast Ethernet 001, fast Ethernet 01 is an inside interface. Fast Ethernet 00 is an inside interface. The only outside interface we have here, yes, you guessed right, is a serial interface that links to us to the internet. Okay, so let's define the inside and outside interface. So IP NAT, that's the command. First of all, we need to be in interface configuration. So interface fast Ethernet 0/0. Yeah, IP NAT inside, and that's how you define the interface roles. Okay, and we go to the next interface FA 0/1. Yeah, and it's also an inside interface. So IP NAT inside. Okay, and that's done. Now interface serial 0/0/0. What do you think it will be? Yes, you guessed right. It is IP NAT out. Yeah, that's an outside interface. So we've defined the interface roles. Okay, the inside and outside interfaces. Next, we need to create an access list to allow the internal networks to be able to translate it across the internet. Okay, so access list, and remember this should be a standard access list. Okay, so IP access list 10. Yeah, permit. Yeah, network 10.10.10.1.1.0 0.0.20.255. Okay. Yep, that's it. Okay. What is happening here? We're saying that the access list should permit IP addresses or devices with IP address coming from this subnet. Okay, and we are saying match this the 00255. We're saying match the first 3 octets. So wherever you see 000 in a wildcard mask, we're saying match the first 3 octets, but ignore any number in the last octet. That is what the 255 does. So for the 255, any number that is in the last octet will be allowed. Okay, so that is what is happening here. All right, let's do another one for the second subnet, and it must be the same access list number. Okay, permit 192.168.1.0. okay, and 0.0.0.255. okay, and that is done. So we've defined our access list. The next thing we want to do is to bind the access list to the exit interface or the outside interface that we defined earlier on. So the command to do so is IP NAT inside source. That's the inside source. Yeah, so we're taking the inside source from the address because we define the inside addresses using the access list. Yeah, inside source list 10. Remember this, I'm using source list 10 because the access list I defined over here is an access list 10. If I define an access list, say 99, or access list, say 1, I will put 1 here. So don't forget that the number there signifies the number of the access list you created for the inside networks. Okay, so access IP NAT inside source list 10. Then we need the interface keyword serial 0/0/0 because that's the outside interface that we defined. Now, if we enter here, Okay, the problem is only one device can use the internet at any given time. No other device can use the internet, because all we're doing is that we are saying that for device that wants to go on the internet, all right, that one global IP address we have will be engaged, will be used by that device. The only way we can get other devices going on in the internet at the same time is when we use this keyword overload. And that is why part is also called NAT overload. Without the keyword overload, translations will not work. So let's use the arrow key to go back a step, and this time add the overload. Okay. Or should I just demonstrate this? All right, let's do this. Let's do this. We've done that. Let's try and go on the internet. Let me delete this. Let's try and go on the internet. My mouse is a bit dodgy, so that's why you hear that. Okay. Oh, I should generate multiple traffic at the same time, and you will see what I'm talking about. We can send a lot of packets to the internet and see whether, but that's a long process. I need to wind down because the video is getting a bit long. Okay, so just for you to know, if you don't define the overload keyword, your address translation will not work properly. So let me just put the overload there. Okay, and there we go. So now all devices can talk to devices on the internet without running out of global addresses. Everyone can do it at the same time. Okay, so now that we've done that, let's just write this to memory. Do write mem. Okay, and that's done. Now let's do some debugging. Okay, so do debug IP NAT. Okay, and we've turned on debugging. Okay, now let me bring this PC up and let's go to the command prompt. We want to send ping traffic to 10.2.2.10, okay, over the internet. All right. Okay, let's do this. Pull up this. Okay, and let me pull up that. I want you to watch the translation as it happens in real time. Oh, this won't allow me to do that. Okay, let's just do this and pull up that. Now you see the translation going on. Okay, let me send the traffic again. Okay, let's just say okay. Let's come back to. Oh, time is going so fast. I want to finish this video quickly. Okay, so let's just say. All right. So whilst the ping is going on, let's look at the translation here. Now you see the translation in real time. All right. It's using these numbers to track traffic. Okay, and that is going through the router. All right. If I use the command, let's do some show commands here. if I say show IP NAT translations, there you go. Yeah, we see the translation working perfectly. Okay, we have our inside global, inside local address working perfectly. All right, so there you are. NAT is working sweet. All right. Okay, I think the final thing we want to look at is frame relay. We've done the PPP. For frame relay, thank God for Packet Tracer. We have a frame relay switch created in Packet Tracer, but we have to configure the frame relay switch for the purpose of this topology. Now, what I realized as well was that my student that came to me didn't know that even Packet Tracer supports frame relay. Okay, but yeah, Packet Tracer support frame relay. Okay, so for you aspiring network engineers, the Cisco guys, this is how to do it. All right, let's go to the configuring tab. All right, and let's call this one frame relay. Okay, switch. Okay, now let's go to interface serial 0. Okay, we want to give it a DHCP number. Frame relay depends on DHCPs. Okay, DHCPs are locally significant layer 2 address. All right, in frame relay, and that is used to sort of direct traffic to the right destination. Okay, or track traffic to various destinations or specific destinations within a frame relay environment, okay, or within a frame relay network, okay. All right, so let's call this link interior, interior to ISP. Okay, this is the link that will go from the interior router to the internet. So let's add that link. Now we go on serial 1, and this will be, let's say, 104, DHCP 104, and let's call it, this is the return traffic, ISP, all right, to interior. Okay, that is the return traffic. Okay, now we go to the frame relay tab, okay, and then configure. So serial 0 is interior to ISP. Serial 1 will be ISP to interior. So outgoing configuration, incoming configuration, and then we add. Okay, don't forget that outgoing configuration. Remember, the serial port on the frame relay switch for outgoing traffic onto the internet must be different from the serial port for incoming traffic from the internet. Okay, and once we do this, we've defined the frame relay configuration. The next thing we have to do is, let's take out this. Yeah, let's take out this link. We can even remove it from here and give it to the frame relay serial 1, because remember we defined, yeah, the incoming into the network to use serial 1 on the frame relay switch. Okay, so let's pick another one here and then configure it. Let's pick another one. I think this one would do automatically. Serial 0 to serial 00 here. Okay, and what we need to do, the frame relay switch is going to provide the clocking. So what we need to do here is to now let me show you something. You see, although we've got this configured properly, all right, traffic will fail because remember we did a PPP and we changed the encapsulation to PPP on the serial interfaces. Now let's try sending traffic from the inside network, all right, to the outside network and see whether it will pass. Now it failed. Why do you think it failed? Because encapsulation over here in the serial at the serial interface is wrong. We have a frame relay switch or frame relay cloud. All right. For the router to be able to talk to the cloud, the encapsulation must be set right. All right, on the router's interface. So let's go ahead and set the encapsulation. Now, if we look at this, let's look at something. Show IP interface brief. Okay, now you see our serial interface is showing us up and down. All right, layer 2 is down. Why? Because the encapsulation is wrong. Okay, so let's go ahead. Global configuration mode. Yeah. Interface serial 0/0/0. Let's set encapsulation. So encap. Yeah, and let's give it frame. That's it. Yeah. And we need to do the same thing on this side as well. Okay. All right. Remember we set the username and password earlier on. So username is admin, and our password is Cisco 1234. Okay. And don't forget where you set enable secret and username password. Username password overrides enable secret. Enable secret becomes sort of a backup security for access to the routers. All right. Okay. So, and remember, by entering the username and the password correctly, I came straight to privilege mode. Why? Because in configuring the username and password, I set the privilege level to 15, which is the highest level. Okay. And so once I'm able to input the correct credentials, the router knows that I am someone with high privilege, and so straight away I should be moved into privilege exec mode. Okay, so that is what is happening here. With other privilege levels, you'll enter into user exec mode, and then you use the enable command to get into privilege mode. Okay. So that's the difference here. I just thought I should point that one out to you. So conf t interface serial 0/0/0. All we need to do here is to set the encapsulation correct. So encapsulation frame. And that's it. Now you see it's changed state to up. Now they can talk to each other because they speak the same language. It's the language they speak over here is frame relay language, and so they can talk and understand each other. So that should. So remember the packet we sent earlier on. Let's send it again and see what happens. Okay, let's drop a packet here and here. Let's see what happens. Sailing. Let's no. All right, now it's working. So I think I forgot to set allow clocking to come from the frame relay switch. So that was the problem. So by changing the cables and picking the DCE cable and starting from the frame relay, connecting that to this, automatically clocking was established. And that is why the link is working. So don't forget, clocking is important here. Okay, clock rate is important. The frame relay is the one acting as a DCE, and our router is acting as a DTE. All right. In real world scenario, we could have a CSU, DSU doing that job, connecting to the frame relay, and then the router acting as a DTE. Okay. So yeah, that is why it wasn't working, because the clocking wasn't right. So by changing the cable, remember I picked this cable, I connected this first, and then dragged it to this, and that's why we saw the clock, yes, icon there. Okay, so now it's functioning correctly. Okay, and these are the little things that they're very little, but they can mess you about big time. So you really have to know what you're doing. Now we've got our frame relay cloud working properly. Okay, working properly. So that sums up the work we started. And this tutorial has been about DHCP, the various problems that people, beginners in networking, seem to be having. Even university students get that problems. So there you go. To set up a DHCP, first of all, if you have to exclude some addresses, define the excluded address range, and that should be done in global configuration mode. Having done that, define your DHCP pools. Where you have multiple subnets, make sure that you define multiple DHCP pools for those subnets. In this tutorial, we had two subnets, subnet A and subnet B, and we defined two pools. We called one pool net 192, and we called the other net 10, meaning 10 network and 192 network. Okay, and we defined the network, all right, with the subnet mask, all right, and we defined default router or default gateway. And we did, for the benefit, for the sake of it, we just did a DNS address, okay? DNS server as well. We did that. Then we set up a default gateway on the switch, and so the switch will know where to direct traffic to. We also did a static default route, all right? Default route on the perimeter or interior router. And we did the same to direct traffic back to the interior router on the ISP. We initially created a PPP link by just changing the encapsulation on the point-to-point link, serial link. All right, we changed it to PPP, and that was it. That's all. That's what PPP is all about. It's that simple. Just change the encapsulation, and that's it. You're done. And then we went ahead to create a frame relay cloud by configuring the interfaces of the frame relay. We had an error there because we didn't ensure that the frame relay was sending out clock information. So we took out the cables, and then took a DCE cable, connected it first to the frame relay and connected it to the routers, and that solved the problem. Traffic is now traveling successfully to the internet. We also set up NAT PAT, all right, port address translation, or NAT overload, and we defined the NAT pool. We created an access list, a standard access list called the 10, and we defined the interface roles as inside and outside. We identified that serial 00 is the NAT outside interface, and FA1, FA2, FA0, FA1, we identified them as the internal interfaces. So we use the IP NAT in command to define those, and IP NAT out command to define the outside interface role. And then we bound the interior IP address created in the access list, all right, to the outside interface, and used the overload keyword. And don't forget, the overload keyword is so important, because otherwise your NAT won't function, your parts won't function properly. We did that. And here we are. Everything is working as it should. I hope you have enjoyed this tutorial, but watch out for more of such tutorials coming your way. I'll be doing one on subnetting. It's one thing that a lot of people seem to have a problem, but I have a very simple way of getting your subnetting questions correctly, especially in the Cisco exams. And I want to say, I want to pay tribute to Lazaro, Laz on YouTube. I can't remember his name right now, but he's from Networking Doctors. He does some very good videos as well. So tribute to Laz, great tutor. I encourage you to watch his videos as well. He's a great tutor, and he nails subnetting very well. I will bring in my version of subnetting as well to you. So watch out. I'll be also recording a video on HSRP and redundancy protocols and many others to come. So watch this space. Leave me comments as you watch my video and tell me how I can improve things. Okay, it's been a very long time recording this video. I did a very in the morning ride from waking up from bed, so pardon my husky voice. Okay, but I hope we do this again right here on YouTube. Send me your emails, LarsyUK, LARSEYUK32 @gmail.com with your questions and your suggestions on how to improve my tutorials. God bless you for watching and keep networking. Bye.